Hello once again. Good day, everyone. This is another sample video tutorial for physics this time. This is for rectilinear motion or motion at constant acceleration. So let me share with you the problem. According to the problem, a rock is thrown upward from the ground. Its height in feet above ground after t seconds is given by the function negative 16t squared plus 20t. We are going to find the number of seconds it took for the rock to reach its maximum height. So again, a rock is thrown upward from the ground. Its height above ground after t seconds in feet is given by the function negative 16 t squared plus 20t. We are going to find the number of seconds it took for the rock to reach its maximum height. Meaning, we are going to determine the time it would take for the rock to reach the maximum height. So if you are going to write down, we are going to write down the equation. The function relative to time is negative 16 t squared plus 20t. So that is the equation. And that's basically the equation for the height. Negative 16 t squared plus 20t. So if you are going to determine the change in height relative to the change in time, we can say we have dH over dt. Any equation or any relationship with the change in time, change in height relative to the change in time will definitely give us the equation for the velocity. Remember, the velocity is, again, change in distance divided by time. So if there is a change in height divided by the change in time, that is basically an equation for the velocity. So using this equation and using differential calculus, our process for differentiation, we can say that the velocity is equals to, you get the differential of negative 16t squared. That would be negative 16 times 2 times t raised to 2 minus 1, which is basically t raised to the first power, plus the differential of 20t, and that is 20. So the velocity equation is simply negative 32t plus 20. And remember that at maximum height, okay, since what we are going to determine is the time it would take for the rock to reach the maximum height, the condition at the maximum height relative to the velocity is 0. Okay. Once the rock hits its maximum height, its velocity will be set to 0. So that means if you are going to equate this velocity to 0, that means you have negative 32t plus 20 is equals to 0. And applying the basics of algebra, transposing to the other side of the equation, those with variables and the constant in the other side of the equation, then we will have the value for the time, which is equals to 20 divided by 32, which is basically equals to 5 over 8. And do not forget to write down the unit. seconds. So our answer, the time it would take for the rock to reach its maximum height is 5/8 seconds. This will be our answer. And that would be all for today. I hope you have learned something from this. By the way, this is again Dr. Ramela B. Ramirez at your service. I will still see you on my next blog.